All right, we're about to pull back the curtain on a piece of technology you use every single day, but you probably have no idea it's even there. It's the silent, incredibly powerful engine that handles your money with, like, absolute precision. Welcome to the world of mainframe transactions.
So think about the last time you bought something, maybe a coffee, with Tap to Pay. You tap your phone, you hear that little beep, and you grab your drink. The whole thing feels instant, right? Almost like magic. It's so smooth we just don't even think twice about it.
But here's the thing, it is not magic. In that one single second, a super complex, high-stakes conversation just happened across the globe, bouncing between your brand new app and systems that are decades old. So what really went down in that blink of an eye?
Well, the entire foundation of our digital economy, from that cup of coffee to a multi-million-dollar wire transfer, is built on one core idea. A simple but totally unbreakable promise that makes sure your money is always, always safe.
To really get that promise, we first have to define what we mean by a transaction. I know it's a word we throw around all the time, but in the world of computing, it has a very specific, and I mean critical, meaning.
And this right here is the heart of it all. A transaction is an all-or-nothing deal. When you buy that coffee, the money has to leave your account and arrive in the coffee shop's account. Both of those things have to happen. If either part fails for any reason, the whole operation gets wiped clean, like it never even started. There is no almost, there is no in-between.
And you really can't overstate the stakes here. Without this absolute guarantee, every payment, every deposit, every single time money moves, it would just be a roll of the dice. Your money could literally vanish into thin air during a transfer. Modern banking as we know it just couldn't exist.
So, to make sure this promise is never broken, computer scientists came up with 4 golden rules. They call them the acid principles. First up is atomicity, that's our all-or-nothing rule we just talked about. Then you've got consistency, which just means a transaction can't break the rules of the system, like creating money out of thin air. Third is isolation, which makes sure that your coffee purchase and the purchase of the person next to you don't get all tangled up. And finally, durability. This is the promise that once a transaction is done, it's permanent, it's locked in, even if the whole system crashes 1 second later.
So who enforces these rules trillions of times a day without ever messing up? Well, for the last 50 years, the undisputed champion of making sure transactions are perfect has been the mainframe computer. Let's talk about its superpower.
To get why mainframes are so special, you've got to understand 2 different kinds of work. On one hand, you have batch processing. That's like letting your mail pile up all week and then opening it all at once on Sunday. But then you have online transaction processing, or OLTP. That's like answering every single text message the second it arrives. When you're at an ATM, you need that instant response, right? That's OLTP. And that is what mainframes were born to do.
And this is exactly why mainframes are still the backbone of global finance. They deliver this perfect triangle of abilities. They handle a massive volume of requests, they respond with incredibly low latency, we're talking milliseconds, and they absolutely guarantee the highest level of data consistency, making sure every single transaction is perfect.
But, the mainframe is just the hardware, the box. The real magic, the wizardry, happens in the software that runs on it. So let's meet the unsung hero of global finance, the guardian of transactions.
It's called CICS, and for decades, it's been the transaction processing monitor beating at the heart of the world's biggest banks, airlines, and insurance companies. You can think of CICS as the ultimate air traffic controller for money. It's the traffic cop and the rule enforcer, making sure every single one of those ACID principles is followed. No exceptions.
Honestly, the best way to really understand its power is to see what happens when things go completely wrong. So let's imagine a simple bank transfer. Account A is sending $50 over to account B.
Okay, so the first step happens. CICS kicks off the transaction and the program debits $50 from account A. Now, at this exact moment, that money is kind of in limbo. It's left one account, but it hasn't landed in the other one yet.
And then, bam! Disaster strikes. A network cable gets cut, the server loses power, doesn't matter what. The connection is lost before that $50 can be credited to account B. So, where's the money? Did it just poof, vanish into the ether?
Nope. This is where CICS gets to be the hero. Because the transaction didn't complete, CICS automatically performs what's called a rollback. It basically hits the big red undo button.
instantly reversing the initial debit and putting that $50 right back into account A. The crucial point is, the system is back to where it started. That all-or-nothing promise, atomicity, is perfectly preserved. No money is ever lost.
Okay, so now we get the promise, and we've met the guardian that keeps it. Let's connect all this back to our 1-second coffee purchase. How does your shiny new phone app talk to this 50-year-old titan of reliability?
The second you tap your phone, an encrypted request starts its journey through layers of modern software. A really key piece here is something called middleware, which acts like a universal translator, letting your new app speak the same language as the bank's old-school system. This middleware securely hands off the request to the mainframe. From there, CICS instantly spins up a transaction that checks your balance, debits your account, credits the coffee shop, and sends an approved message all the way back to your phone. And this entire round trip, the whole shebang, happens in less than a second.
So, you might be thinking, okay, that's kind of cool, but this technology has roots in the 1960s. Why are we even talking about it? Well, it's because the problems it solved are actually more relevant today than they have ever been.
And that's really the key takeaway from all of this. The specific hardware, the software, that stuff will always change. But the fundamental need for trust, for reliability, for that unbreakable all-or-nothing promise in our systems, that is absolutely timeless.
I mean, just look at today's hottest tech architectures. Microservices, distributed systems, event-driven platforms. You know what they're all grappling with? The huge challenge of making sure data is consistent and reliable across dozens, sometimes hundreds, of separate services. They are, essentially, trying to recreate the bulletproof guarantees that a mainframe running CICS just gives you, right out of the box.
Which leaves us with a final, kind of provocative thought to chew on. As we build all these complex distributed systems in the cloud, are we just spending massive amounts of effort to painstakingly rebuild the exact same principles of transactional integrity that the mainframe perfected half a century ago?